Hello everyone and welcome to the session about Azure Sentinel. My name is Rueefli. I'm working as a solutions architect at the Scopewise. I'm a multi-year Azure MEP and you can reach me over Twitter or using the email address below. We'll start right now because we have a lot of content. So if you have any questions during the session, please feel free to raise your hand or to unmute yourself and just place your question. We will also have about 10 minutes at the end of the presentation for other questions as well. So let's start with this slide here, why security is different in the cloud. We are all aware that the classic perimeter, speaking of a firewall or let's say a web application firewall, is not enough today regarding all the connected applications we are using. The traveling we are doing, well, maybe not that much right now, but devices and users and data are traveling more than ever. So we need different ways to either prevent attacks or also detect attacks when they're happening. So we all know that not all attacks can be prevented. So assume breach is a good, let's say, starting point. If you assume you're going to have a breach somewhere, your data is going to be leaked, your password is going to be reused or leaked, then it's a good advice to keep that in mind that this can happen. It happened to big as well as to small companies already. Also here in Switzerland, we have a few popular cases where companies went down completely. So just by the fact that they did not react quickly in terms of threat alerting and protection, where they got infected with a malware like crypto software and so on. So the cloud is changing a lot of things. One of the things is that we, as I said, we have to think about different parameters. Not only the network firewall in our data center is important. No, it's mainly the identity. So you need to protect the identity. Your identity is the key to access information. Your identity is also the key to access your device. So wherever you're traveling with your device, protect your identity, protect your device, protect the data you're accessing. That's the most important thing. So speaking about those three pillars, there is a fourth one. So protecting also means control. So we need to control what happens. What is a normal behavior from perspective of a user device? What is a normal behavior of an identity? And also a normal or abnormal behavior of data traveling around our devices and over the network. You might be familiar with the cyber kill chain. This is a standard, let's say, breach assume strategy, which is not only theory. By fact, more than 80% of the attacks by today still happen over the email channel. So user clicks on email, he opens an attachment. Well, while we have a lot of industry solutions to prevent from rogue attachments coming into our mailbox, there are still some sophisticated malware which is mutating itself and it's not detectable on a pattern-based solution. But more than ever, we have this problem here. User clicks on a link and we have the phishing and spear phishing attacks behind the scenes, social engineering, all the things we know. So this exploitation then goes lateral until it reaches, let's say, the heart of your company, the secret sauce. These terms here, they are called tactics. We are going to hear them more later on during the presentation when I show you the demonstration in Sentinel. Those are attacks defined by the MITRE framework. So these terms are standardized. If a security analyst talks to you, oh, we might have a privilege escalation or a lateral movement, then it's well known in the security community what that means. So those tactics are also used in Sentinel to detect anomalies and react to them. So these are important terms to remember. What is SIEM in general? It's about detecting threats, anomalies, and react to them. So detecting is one, but detecting only doesn't help you from being bankrupt or going down with your company. You also need to react. The challenge is, especially with detecting and reaction, or let's keep it with detection, is the traditional SIEM systems require a lot of infrastructure and maintenance, especially when we are talking about data. And I mean data in general, like what type of information are we going to Pascal, is there no presentation? So you can't see the slide deck?
No,
okay.
I can't.
I can see it.
Oh, okay, then it's me. Okay.
Challenges with the data we are collecting is that the amount of data which we produce in the cloud, or let's say the cloud platform or the cloud services produce, and in terms of amount of data, log files, sensor data, and also the information we produce while traveling around, logging in from all over the world. It's just a lot of data you would have to proceed and process with the traditional SIEM system. We have a lot of signals which may not make sense, a lot of sense to us. So we need to be able to interpret those signals of all the sensors, what they mean. And to do that, we traditionally have a lot of disconnected products. So let's say beside the antivirus solution, we have an intrusion prevention system, we have a firewall, we have an anti-malware solution, and all those products together, they can't fit the demands and the different functionality of the cloud applications. And I'm not talking about, let's say, virtual machines only, which is of course, it's traditionally a virtual server running in a different data center if we talk about Azure. But I'm also talking about, or mainly talking about, the applications which we have not that much control over the platform. So Microsoft 365, Azure AD. So those are our solutions which are broadly used, but we don't have those type of control we usually need in our local data center. So defending the applications and data and identities in the cloud, they also require different skill and tool set. We cannot use our internal firewall to protect us from, let's say, an Azure AD authentication breach. So that doesn't help because the firewall does not have access to the Azure Active Directory platform behind the scenes. So to help with that, we need some tooling around. And one of the great innovations from the Microsoft Cloud Platform is the security graph. While Microsoft is using the security graph for itself to protect the Azure platform, to protect every service, every customer on the 365 solutions, they also have a lot of data coming in, of course, a lot of attacks, trillions of attacks a year, which they have to process and analyze and of course protect the customers and themselves from the attacks. So all this information they store and process within a large database called security graph. The collection and analysis is done automatically by machine learning and AI models, but also by hundreds, if not thousands, of security analysts from Microsoft and third party. So to feed the machine learning models and become better and better, to have a lower false positive rate and so on. Those detections and anomalies, let's say the lessons learned from Microsoft are then fed back to the products which we are all using. So Azure Security Center, AAD, Identity Protection, Defender for Endpoint, and so on. And the reactions from the customers, how they behave with the tooling, how they react to incidents, respond to alerts, it's also then fed back to the data collection and analysis. So Microsoft knows how the users or the end users, the customers are using the products and maybe react to alerts which they classify as false positive. And this is an ongoing process. It goes up and down and around and improves the whole security landscape. Azure Sentinel is a service called as a SIEM from and in the cloud. It's a cloud-based solution leveraging AI, modern machine learning, AI, and threat intelligence. The service is running in the cloud. There is no software you can install on-prem. There is no way to have that some way hybrid, some way you can, let's say, have the data on-prem and let it analyzed by Azure Sentinel. It always has to be put into the Azure Sentinel area, or let's say workspace. We will see what that means later on. So these are the main components of Azure Sentinel. It's the logs, of course. We need to store logs somewhere to be analyzed. Logs produce maybe alerts with specific detection rules. We have automatic alert creation, and then sorting the alerts into incidents means that a person has to investigate specific alerts. And workbooks are there to visualize the raw data and also the security, let's say, status. So workbooks are in general are dashboards. We have hunting queries. So the hunting queries can be manual hunting, like proactive hunting queries to see how your security posture is. We can use them for forensics if already something bad happened. So we can use the hunting queries to dig deeper and investigate what happened from the beginning to the end of the attack chain. The playbooks are there to automate responses mainly to incidents. So if you have an incident which is clearly identified as a bad thing happening on a device, maybe just making an example, then you can isolate the device automatically, or maybe you just send the administrator an email, hey, please have a look, something bad is happening. The playbooks are, let's say, they are intended to free you from pretty clear procedures. So if you have a type of incident where the reaction is pretty clear, it's a harmful thing happening, and you know how to react, then why not link it with a playbook, which is then maybe blocking a user. Let's say preventing them from logging in again, or invalidate the user's access tokens. So playbooks are used to security, orchestration, and automation response method. Notebooks are there to perform advanced hunting. So hunting in terms of forensics, take what happened when you had a breach, collect all the data, and then have a security analyst digging into it and see what happened. While this can be a completely manual thing, the notebooks are there to also half automate this process. We will see that later on what that means. So these are the main components of Azure Sentinel. Let's have a look how that. Let's see how that looks in reality. So this here is Azure Sentinel overview dashboard or console. We have logs, we have incidents, the workbooks, the notebooks, and there are also other useful things, like we can see how our security posture was over the last 14 days, for example. So let's wait for the data coming in. So we see that during this time frame, we had some pretty anomalies, I would say. not that much here. And on the other side, there were a lot of days which nothing really bad happened. So if we wanted to dig deeper, then we would click at this point here, and it will take us to the raw event data, which resulted in this graphical peak here. So now we see all the raw event data, why we had a peak here. So there were risky logins. Azure AD identity protection detected risky logins. I see the user principal name who has logged in. Of course, of the raw data, I also see the IP address, and also I have information about the location of the user where he came from. So going back to the portal, I now know that the user was AC AD 0. So maybe I have more information about that user. I'm going to the entity behavior. Last 24 hours, I select again the 14 days, and here it is. So it's related to 7 alerts. Let's see what that user has done during this time frame. We had the risky login, but there were also other activities. It seems that the risky logging was produced because he was logging into his application from a Tor browser. The ones who know Tor, you know that Tor is connected to, let's say, a network of anonymous VPN proxies. And this produces anonymous IP source addresses if you log in from a Tor browser. If we go down here, well, this is nothing new, always those risky logins. Okay, so far so good. I could now dig deeper into those incidents, but let's keep that for later on. While I also see the trends, like if my incidents alerts are going up or down, I also see the overview of the incidents. And if it would be an attack which was which spreads over different countries, over devices from my company all over the world, I would see them here in the map. So I have an indication where to react quickly and maybe which location is not affected yet. Let's go back to the presentation and see how this works together and where do we get the logs. An important thing to know is that Azure Sentinel is a service which is acting on a tenant level, so it's not something which lives in a subscription, but it uses data which lives in a subscription. So Azure Sentinel analyzes data from a log analytics workspace, one or more workspaces. A lot of times customer asks, can I also use attached Splunk? We already have a lot of data in Splunk or other log management tools. No, you can't. So the base is always a log analytics workspace. So the data has somehow come or flow into the log analytics workspace. So that means the workspace is the most important and integral part beside the security graph for Azure Sentinel. That's the first thing you need is a log analytics workspace. Data collection is then configured using different connectors. We see that in action a bit later. So we connect different systems to send their logs, their debug or let's say analytic and audit logs to send them into the log analytics workspace where Azure Sentinel can analyze them and process them using the machine learning models and also using manual analytic models we can create by ourselves. So what we see here on the top right is a view on the log analytics workspace with its tables. So security event is a table. The heartbeat is a table. Sign-in logs from Azure AD is a table. Those are called tables. That's an important thing to know if we talk about RBAC later on. And this here is just a workbook from Azure Sentinel visualizing the data in another way than with these diagrams. So Azure Monitor Log Analytics is the service you need to onboard first. Then you need to make sure that you understand the data access layer. So role-based access in Azure generally, you have those three common roles like reader, contributor, and owner. So if you assign the reader role to a log analytics workspace or the resource group or the subscription above, then the people or the person owning this role can read all the data in the workspace. So any table, any type of data in any table is then readable with the general reader access role. So beside the data layer, we also have the analytics layer of Sentinel, but let's stay a moment on the data layer. We can configure RBAC-based access on the workspace, but also on the tables. While the workspace handling is very easy, this requires a little bit of API callings. So if you want to restrict access to certain tables for certain users, then you have to make sure that they are not already configured as readers on the workspace layer, but then on specific tables within the workspace. On the analytics layer, let's say work with Sentinel, we have different roles. Sentinel reader, Sentinel contributor, Sentinel responder, where the Sentinel contributor is used to configure Sentinel. Sentinel reader is used for security analysts, or let's say those who only need to access the logs and read the data. And the Sentinel responder is a role which is able to read and also react to incidents. So make sure you understand the role-based access model before you giving everyone in your company access to the security data, because we will see later on that there are really, let's say, sensitive data in it. You don't want to have everyone accessing those security logs. Speaking about the workspace design, that's the best practice. If you have a single tenant, create a security workspace, create a single workspace which collects all the security relevant logs. If you need to collect other logs like debug logs for application, tracing logs from your apps, your functions, whatever, please use another workspace, because you don't want to have those mixed with the security logs. Otherwise, the developers also need access to this workspace just to see their trace logs from the applications, which could result in, let's say, a lot of people having access to sensitive security logging information. The cons of this, let's say the negative side of this is that, data governance could be a limiting factor. That's correct. If you have data residency limitations like security logs from Asia should stay in Asia and so on, a security workspace, a single one, might not fit your requirements. Another option, of course, is to have a single tenant but multiple workspaces. So Sentinel always works with security, or let's say log analytics workspaces, and you can have multiple of them. While this might fit to your data residency requirements, it also produces headaches, because you have to configure the workspace multiple times. The good, let's say the good message here, or the good possibility you have to react to that, is automation from Sentinel itself. So there is a REST API or multiple REST API endpoints. There is also a PowerShell module which you can use to automate the Sentinel configuration. But tools like analytics rules you have to configure for each workspace. So make sure if you're going to have multiple workspaces, you think about automating the configuration here, because otherwise you will click around with your mouse a million times. In this situation, if you have multiple tenants, this is one way. Then you have also multiple Sentinel consoles, and yes, let's say the whole management is then doubled. Might not be a useful thing, but there is another thing. You can have this situation where you have multiple tenants. I have some customers which have 2 or more tenants. So if you want to analyze those logs from the different tenants from a single pane of glass, then you can connect your Azure Sentinel to the workspaces living in a different tenant using Azure Lighthouse. For those who don't know Azure Lighthouse, it's nothing more than cross-tenant RBAC functionality on a Azure resource level. So with the user from this tenant, you will then be you can assign permission to a group of users which has then access to the security workspace in the other tenant without switching content, without the need for guest invitations and so on. This is a typical scenario if you're a service provider, managed service provider, you have multiple customers. Of course, each one has its own tenant, but you want to have a single pane of glass for all your customers using a single Azure Sentinel instance. So how does the data flow into Sentinel? There are different ways to, let's say, put data into the analytics workspace, which is then being processed by Sentinel. One is, of course, the easiest one is to activate the connectors. Just activate the Azure Active Directory connector, and your sign-in logs and your audit logs are then flowing into this workspace, and Sentinel is going to analyze it. There are tons of connectors, just mentioning a few here. The list is big. It's getting bigger and bigger every month, almost every month. Another way to let's say feed data into this workspace is by using the monitoring agent from Azure VMs, from non-Azure VMs, from physical servers, wherever they run, you install the monitoring agent or the brand new Azure agent, and you feed the data into the log analytics workspace. If it's an appliance, usually you have syslog as a delivery method for appliance-based logs. You forward the log to a syslog component, a syslog server, and the syslog component forwards the information to a so-called CEF collector, common event format collector, and this collector has an agent which is then similar to the Linux agent here and forwards the data to the analytics workspace. So that's a typical scenario for integrating your on-prem firewall into Sentinel. There is also a API, a REST API, the so-called Log Analytics Collector API. You can fill or feed any custom log you need to using the REST API. There is also a connector from Logstash if you already have using Logstash and you want to feed those logs into Log Analytics. There's a easy way to do that. If you have some custom applications, you can call the REST API and feed your logs into the Log Analytics workspace. The third option or the fourth option is a logic app send connector. So you can use a logic app to send any type of data into Azure Sentinel. Well, behind the scenes, they are of course fed into the Log Analytics workspace. It's just for to ease the diagram that it's going into Sentinel directly. Sentinel is not collecting. Sentinel is only analyzing data. So let's see how we can enable collection of data. So here in Sentinel, we go to data connectors. I already enabled a bunch of those built-in connectors, but I did forget to enable Azure Security Center. So I want to feed the alerts and the information from Azure Security Center into into Sentinel. So I open the connector page. Of course, I need to have the right permission depending on the connector. It's a global admin permission or it's a owner or at least contribute the permission if it's an Azure resource. So with this, I'm going to enable data collection for both of those subscriptions, which are onboarded in Azure Security Center already, and that's it. So from this point on, information from Azure Security Center is flowing into Log Analytics and therefore Sentinel. If I go to the log section here, it's the same if I would open the Log Analytics workspace and go to the log section. Here I can browse the log data. So if I search for the Azure AD sign-in log, where user display name, or let's take the user principal name. User principal name, what contains was like AKD something, the user we have seen before. We have all his logins, but it's not within the last 24 hours. It's from the last 7 days also. That could be. Okay, let's search for the demo user. Demo 02, I guess, was it? So we have a lot of sign-ins from this guy. And I have all the information where he came from, and maybe I want to dive deeper and let's see if he always is logging in from Switzerland. So let's extend this column here and filter it where country or region contains or not contains or is not equal CH. Okay, so we have some logins from Germany. Do we have logins from others? Let's count that stuff. Summarize, count by country or region. Okay, we have 12 logins from Germany. So if I want to dive deeper, then I select those logs and I'm going to analyze what happened there or why we had those logins from Germany, because this user, for example, should only work from Switzerland. So analytic rules. The next important thing are the analytics rules, because I don't want to dive deep into the logs every time I have a suspicious activity. I want to have Sentinel analyzing this for me, either automatically by Microsoft delivered templates for analytic rules or by rules I produce myself. And this is the next demonstration. So analytics rules are enabled by enabling the rule templates. That's one possibility. There are a bunch of predefined rule templates here. Let's say I want to create incident based on Azure Security Center for IoT alerts. I just go to create a rule. I can give it another name. Let's keep it like that. So it says on the top. I can include or exclude specific alert types, and I'm only interested in severity alert of low or higher. The information one I don't care about, and create a rule. From this point on, if I have a Azure Security Center for IoT alert which is raised, it will be shown here. And I've also enabled a bunch of rules for demonstration already. So let's make an example for a custom rule. I want to know if someone is going to change the conditional access policy or any conditional access policy on Azure AD. I want to know that. So this is a custom rule I just created. I'm going to edit it to show you the purpose. So it's also a title, the tactics, the severity, which is this alert going to raise. And here I have the rule logic. So audit logs where operations update policy, blah, 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 blah. Some properties. And if that is going to produce a result greater than 0, every 5 minutes with data from the last 10 minutes, then this is going to create an incident. Here, it's going to create an incident. We are going to group the alerts or the incident into a single one if the entities are the same for about 1 hour. So if the same user is creating, or let's say modifying 10 different conditional access policies, then now I don't want to have 10 incidents. I want to have them grouped into a single one, and this then looks like that. Here I have then an incident like this one. I have one incident. This incident has 2 related alerts. Maybe we see another one here. Yes, here we have the conditional access policy incident. We have 4 related events and 2 alerts. That's the combining of alerting and incidents into one. So I don't want to have tons of incidents for the same user behavior at a given time. With this analytics, you're going to produce incidents. So already the next demonstration, if you're going to work with incidents, then let's take one here. We have a Mimikatz prevention. Okay. Oh, was a security malware, even a registry access, uncommon file was created, added a run key. Okay, this I want to dive into what here happened. So let's investigate this incident. So the security graph shows me a deep dive on what happened with this information here. So there was obviously a user behind the scenes accessing the registry. The device was this machine here. Okay. So SCDemo02, let's go back to the entity behavior. This was the machine SCDemo2. I want to know what's going on there, and we have a lot of activities here. Suspicious, suspected credential theft activity, Mimikatz was executed but prevented, and so on. Okay, so this is too much for me now. I want to isolate this machine. So this was really a rogue behavior. I want to react to that. So let's go to the incident here. This was this one. Let's go to the alert. Sorry. Let's go to the alert Mimikatz tool. In this situation, it was the same machine. And now I have the playbooks here. Playbooks, as I already told you, they are here to automate reactions. Either fully automated or half automated, or let's say semi-automated. In this case, I want a semi-automated reaction to this rogue behaving device. I have a machine here. This one is the SCDemo02, which is behaving really bad. Also the Tor browsers here. So from a security analyst perspective, I want to react quickly and isolate this device. My administrator of Azure has already prepared a logic gap for me. This is called isolate MDATP machine. Okay, this I'm going to run. So what happens now is the playbook is going to react on the incident, so that all the dynamic data of the incident is being fed to the logic app. So the context of the incident is there, so they already know that the machine has a specific IP address and the name, and it's calling MDATP to isolate the machine from the network. So from that point on, I'm safe. I can investigate the machine. I can dive into the alerts and generate analysis packages, get all the files from the machine without having the machine being on the network, spreading the attack on a lateral way. Okay, so I want to have this device back again communicating. So now I'm on the Defender Security Center and release that device from isolation. This was just a demonstration. So within a few seconds, it's coming back. Another way using logic apps is for notifications, for example. Here I have my SOC mailbox. Anytime an incident is raised, I will receive an email. This can also be a more sophisticated reaction than just sending out an email, but it's an easy way to show what's possible here. Every incident is then sent to the inbox with some information, and I also got the deep link to the incident here, and I can open it directly in my browser. And it's directing me to the respective incident. So these are just two small examples how you can automatically react or semi-automatically react to incidents produced in Azure Sentinel. The workbooks are pretty easy to understand. They're just dashboards. So every connector usually comes with a set of predefined dashboards. And we have the hunting rules. Also, the connector usually has its own rules for collecting and analyzing the data and anomalies, but it also has hunting rules, which are automatically imported by Microsoft. It's also a default set of hunting rules, but there is the community in Azure Sentinel where you can get more than just the Microsoft built-in examples. Sorry for that. Sentinel, then I go to the workspace. And here we have the community setting. So if you go to the Sentinel community, it will reach a GitHub repository with a lot of examples, like detection rules, the playbook examples, workbook examples. So if you're not happy with the stuff which is there by default, then go have a look at the content of the community. Just to give you an idea about the workbook, it's the Azure AD Audit Activity and Sign-in workbook. Let's see what that can give you here. It's just an overview. Yeah, it's a dashboard. So nothing more but a dashboard, but nevertheless, it has a lot of information which you can get from here and dive deeper into the raw data behind it. And on top of that, it's also a good starting point if you want to know which query is behind this graphical interface. So we go to Edit. And if you're not really familiar with the query language of log analytics, then you open this one here and you see the raw query behind this graph. Also a good starting point. So again, the automation with playbooks, it's there to respond immediately, automatically, or if you have an incident which clearly identifies a rogue device or user, why not react to it and block the user or block the device from spreading its rogue activity even more? So integrating with an existing SIEM is pretty easy. So there is a way to analyze Sentinel data from an on-prem SIEM. So if you already have an existing tool like IBM QRadar or Splunk Enterprise, you might feed the alerts into your on-prem system and analyze it further from your on-prem system on Azure Sentinel. A bad idea is to say, well, we already have IBM QRadar. We use Event Hub, which is possible, just to forward all the raw event data to an IBM QRadar system. As we remember, you are then mainly in charge to produce the machine learning model in the tooling here, because IBM QRadar, while this is a good tool, it doesn't have the power of Azure Sentinel with all the training signals of the cloud behind the machine learning model. So forwarding alerts to have a single pane of glass on-prem is fine, but let's say forwarding raw event logs to your on-prem system is not the way you should go forward. The last thing to mention here, we cannot dive in too deep into this. This is really, if you're a security analyst, this is something interesting for you. If you have to dive deep into analysis what happened, like let's say a forensic analysis, then the notebooks can help you out. So where automation ends, you have the manual analysis or semi-manual analysis using the notebooks. And this is one possibility here. The notebooks are structured using Python scripting and custom query language skills, log analytics language queries. And those notebooks are there to have a standardized processing of well-known attacks. So there are also a lot of examples available here. And to show you the last demonstration, this is the notebooks demonstration. It's based on Azure Machine Learning Service. So this is one notebook I opened, and it's just a combination of text. Let's say the steps describe what I have to do, combined with Python code, combined with query language. So more or less, it's just a manual how to proceed with an investigation in a standard way. So yes, as a security analyst, I know, okay, I've done this 100 times. First step, second step, third step to get to the data. And at the end, I will have a report. About the costs, to finalize up, it's, of course, this is not for free. Log Analytics has a cost, the data ingested per month and gigabyte. If you need more than 30 days of default data retention, then you need to keep an eye on it. On the Azure Sentinel side, there is also a price for analyzed gigabytes a day, and the default data retention is 30 days. If you need more, then you also need to pay more, of course. But the good thing is, and this is really good, from the Azure Sentinel perspective, all the security products from Microsoft, they are for free. So Azure Sentinel doesn't charge you for analyzing all the Defender stuff, all the Office 365 activity, and Azure AD, Security Center, Cloud App Security, Microsoft Information Protection. This is all for free. So you only pay for the relatively small amount of data from those logs you put into Log Analytics. So how to start? To recap here, if you want to start with Sentinel, then I would really suggest that you choose Workspace Design according your company policies in terms of data residency or who is going to have access to it. Define a process and how and who will work with alerts and incidents. It doesn't make sense if you create or the system creates 100 incidents a day just because you enabled all the possible log analytic rules and nobody is taking care of them. Onboard common connectors. Of course, the identity connectors are most important, then all the Defender stuff and Office 365. I wouldn't start with all the connectors, but focus on the most important thing. Like I said before, identity, apps, and data. Activate the built-in analytics rules for all the products here and add custom rules as needed. So with that, I really want to thank the sponsors for having this conference, for sponsoring the conference, and also for Drago for having me here. If you have questions, I will be still around for about 5 to 10 minutes. If you have questions after the event, you can reach me over email or just feel free to write me on Twitter. I hope this helped you a little bit to get an insight how to start and how Sentinel can help you to leverage your security posture in the cloud. Also, I'm really happy if you give me feedback. using the QR code here. I'm always eager to have feedback, good or bad one. That helps. So if you have questions, feel free to type in the chat window, raise your hand, or unmute yourself. Thanks, Kevin.